Hi, welcome to the final exam review example part C. Again, we have our problems divided into A problems and B problems, and we are going to, in this first video, go through the A problems, starting with 1A. What is the area of the given trapezoid? So the first thing I'm going to do is I'm going to go find the area formula for a trapezoid. So on my formula chart, which I have open in another tab, my trapezoid, right here, area equals 1/2 B1 plus B2 times h. And I can see the bases are those two parallel sides, and then the height must hit at a 90-degree angle. So I'm going to write down my formula. Area equals 1/2 B1 plus B2 times the height. So my area equals 1/2. My two parallel sides are going to be 13 and 8. 13 plus 8, and then my height is 4. So my area is 1/2 parentheses 13 plus 8 close parentheses times 4. When I hit enter, I get an answer of 42, and it's area, so when I put my units inches, they are square inches. All right, let's look at 2A. If the measure of angle ACB is 36 degrees, find the area of the shaded sector. So I'm going to go back to my formula chart and look at area of a sector of a circle. A equals x over 360 pi r squared. What is the x? So I can see the x is that angle, which is the same as the measure of the arc, and then r, of course, is radius. So it's the measure of the arc over 360 times pi r squared. So I'm going to do the measure of the arc over 360 times pi r squared. The measure of the arc is 36 degrees over 360 times pi r, my r is 5 inches, squared. So I'm going to do this without the pi. 36 divided by 360 times 5 squared gives me 2.5, and then I still have that pi. So this is 2.5 pi. And I'm using inches squared because it's area. The approximate answer, if it's multiple choice on the actual test, it's nice to have both. So that way, if I don't see a 2.5 pi, I know I can find the approximate answer. I'm going to take 2.5 times pi, and I get 7.854 square inches. There are my exact and my approximate answers to number 2A. Let's look at 3A. 3A, the diameter of a sphere is 56 meters. Find the surface area to the nearest tenth. All right, so surface area of a sphere. Let's look at our formula chart. Surface area of a sphere. So I have my lateral area formulas, my surface area formula, so the second column, and then my volume formulas. So sphere, my surface area is 4 pi r squared. So my surface area is 4 pi r squared. Now, they didn't give me the radius. They gave me the diameter is 56 meters. So if the diameter is 56 meters, that means the radius, I have to do 56 divided in half. My radius then, 56 divided by 2, is 28. So my surface area equals 4 pi times 28 squared. So 4 times 28 squared is a surface area of 3,136 pi. Now, since it says to the nearest tenth, it probably does want me to multiply that pi in. So I'm going to hit times pi. And it says to the nearest tenth, so that's one place after the decimal, which is kind of interesting, right? Because one place after the decimal, after that is a 3. So I'm going to have a 0 at one place after the decimal. So 9,852 point, it's just a 0 on the end there. Okay, and my units here are square meters because it's area. Okay, let's look at 4A. Find the lateral area of the regular pyramid. So the first thing I want to do is go and find the formula for lateral area of a pyramid. So again, when I look at pyramid, I have two surface area formulas. The first column is my lateral area, which normally I would use an L. This formula chart uses an S for both, but I'm going to use a capital L for lateral area. So my lateral area equals 1/2 capital P, which I know is the perimeter of the base, times the L, which is the slant height of the prism, so the slanted edge of the prism. So 1/2 the perimeter times the slant height. 1/2 the perimeter of the base times the slant height. My lateral area, 1/2 the perimeter of the base times the slant height. My base is a square, 12 by 12 by 12 by 12. And I know that because it says it's a regular pyramid, which means my base is a regular shape, and regular polygons have all sides the same. Okay, so that means my base is a square with side 12, which means the perimeter is going to be 12 plus 12 plus 12 plus 12, or 12 times 4, which is 48. My lateral area is 1/2. My perimeter is 48. My slant height, remember that is the ball rolling down the side of the pyramid. So that is going to be 20. So my lateral area is 1/2 times 48 times 20, which is 480. And I don't have units on my numbers here, so I'm just going to say units, and it's an area, so squared. Okay, let's look at 5A. 5A, find the lateral area of the cylinder. So again, the first thing I'm going to want to do is go find the formula for the lateral area of a cylinder. And remember, my lateral area is my first column. So I'm going to use a capital L equals 2 pi r h, where my r is the radius and the h is the height of the cylinder. 2 pi r h. My lateral area equals 2 pi r h. 2 pi. My radius now all the way across is 9 feet, then halfway across is 4.5 feet. And the height is 20.5. So my exact answer, 2 times 4.5 times 20.5, is 184.5 pi square feet. My approximate answer, if I multiply this times pi, is 579.624 square feet. Okay, let's look at 6A. 6A, the volume of a pyramid is 64 cubic inches and the height is 4 feet. What is the area of the base? Okay, so I don't know what the shape of the base is for this pyramid, but I do know that its volume is 64 cubic inches. So I know I'm working with volume, and I know I'm working with a pyramid. So I'm working with volume and a pyramid. So let's go look at that formula. Volume for a pyramid. Volume is my last column. And for a pyramid, my volume equals 1/3 capital B H, where capital B is the area of the base. Capital B is the area of the base. 1/3 capital B H. Volume equals 1/3 capital B H. Now they've given me the volume. They told me my volume is 64 cubic inches. That's 1/3 the area of the base. That's what I'm trying to find. I'm trying to find capital B. Oops, I put 1/2. 1/3 the area of the base times the height. The height is 4 feet. Okay, so when I look at this, 64 equals 1/3 capital B times 4. I'm trying to figure out what this capital B is. Okay, so the first thing you might want to do is get rid of this 1/3, or if this number here was divisible by 3, I might do 1/3 of this number, but it's not. So let's go ahead and get rid of that 1/3. Okay, to get rid of the 1/3, what I'm going to do is I'm going to multiply both sides by 3, and that way I don't have a fraction anymore. 3 and 3, and that's going to cancel there. So 64 times 3 is 192 equals b times 4, which is just 4b. So now if I want to know what b is, all I have to do is divide by 4. So 192 divided by 4 is 48. So 48 is the area of my base. And these would be feet, and so my b equals 48 feet, and it's the area of the base, so they are square feet. Okay, let's look at 7a. Find the volume of the cone. So the volume of the cone, volume of a cone, 1/3 pi r squared h. 1/3 pi r squared h. 1/3 volume equals 1/3 pi r squared h. Volume equals 1/3 pi r. My radius is 5. Squared h. Now they didn't give me my height. Remember, h, your height, is your perpendicular height to the radius. What they gave me was the slant height, but I can use that and the radius and this little right triangle to figure out what h is. This is a leg of that right triangle, which means I'm going to subtract the square of the hypotenuse minus the other leg squared. So that leg, which is the height of that cone, equals the square root of 24 squared minus 5 squared. I'm actually just going to put that in my calculator. The square root of 24 squared minus 5 squared gives me this ugly decimal. That's okay. 23.47338919. Notice I wrote down the whole thing and I didn't round it. When I put it in my formula, I want to try to use as many numbers as I can, so I'm not rounding till the very end. Okay, so 23.4. In here, I'm gonna abbreviate it, but I know it's really this whole number, and really even more than that, right? It keeps going. All right, so my volume equals, because this is a rounded number, I'm not going to be able to get an exact answer, okay, because I've already got a rounded answer here. So I'm just going to put the whole thing in. 1/3 times pi times 5 squared times, and then I have this whole big ugly number here, 23.47338919, multiplying by that whole thing. And when I hit enter, I get 614.53. I'm going to round this correctly, so 532. And I don't have units here. This is units, and it's volume, so it's cubed. Okay, let's look at 8a. 8a, the volume of a sphere is 288 pi feet cubed. Find the radius. Okay, so my sphere, the volume, there's a little typo right there. Volume, because I know that's my last column, is 4/3 pi r cubed. 4/3 pi r cubed. Oops, let me get a different color. I just used that one. Volume equals 4/3 pi r cubed. Okay, my volume is 288 pi equals 4/3 pi r cubed. Now, that 4/3, to get rid of that fraction, we have to multiply both sides by the upside down, the reciprocal version of that fraction. So I'm going to multiply by 3/4 on both sides. When I do that, 4/3 and 3/4 cancel out on this side. On this side, I'm going to do 3/4 of 288. 3 divided by 4 times 288. Notice I didn't put the pi in the calculator, which means I'm still going to write it on the paper. So now I'm at 216 pi equals pi r cubed, because my 4/3 canceled out with my 3/4. So then I need to get this r cubed by itself. It's being multiplied by pi, so I'm going to divide both sides by pi, which is great because both sides already have a pi in them, so they're both going to cancel out. And I'm just going to have 216 equals r cubed. I'm going to write this over here. 216 equals, r cubed. Okay, now to uncube something, it's similar to when we unsquare something. When we unsquare something, we square root it. To uncube it, we are going to cube root it. So I need to cube root my 216. Okay, so to cube root in the calculator, we have to hit the math button. Okay, and then if you look down, the first one turns your answer into a fraction. The second one turns it into a decimal. The third one will raise it to the third power. That will actually cube. But look at my fourth one. That is the cube root. So I'm going to arrow down to number 4. Number 4, which is my cube root. Okay, and I'm going to select that one, and it gives me my cube root symbol, and I'm trying to find the cube root of 216, which is 6. So my radius is 6. And my units here are feet, so my radius is 6 feet long of that sphere. It's a pretty big sphere. Okay? All right, let's look at 9A. Sam rolled a die 5 times. Each time it came up even. What's the theoretical probability that it will come up even if he rolls it one more time? All right, so a die doesn't change each time you roll it. Every time you roll it, you have the same probability of getting any number on that die. So the fact that he rolled it 5 times already and every time it's been even has no effect on what the next roll is going to be. So we're just trying to basically, what is the probability that the next roll will be even? Well, how many even numbers are on the die, right? So think about a die. A die is a cube that's got a 1 and a 2 and a 3 and a 4 and a 5 and a 6 on it. So half of them are going to be even, 2, 4, and 6. There are 3 even numbers on the die out of 6 total numbers on the die. So my probability is going to be 3 over 6, which is 1/2. If you forgot how to do that, 3 over 6, math, select number 1 to turn it into a fraction. The percentage of probability is going to be, I'm going to hit math again, and I'm going to say turn this into a decimal, take that 1/2, turn it into a decimal, and then multiply it times 100, and I get 50%. So my probability is 1/2 of the time, or 50%. Okay, let's look at number 10, our final problem. Brandy asked Katie to pick 2 cards out of a deck and keep them. If Katie first picks a 5 of hearts, what is the probability that the next card she picks will be the 5 of diamonds? Okay, so she's already picked out a 5 of hearts. And then what's the probability that the next card will be a 5 of diamonds? So she is doing 2 probabilities. Okay, so when I look at this one, I want the probability that she got a 5 the first time of hearts, and that she's going to get the 5 of diamonds the second time. Okay, all right, so let's see. Probability of getting 5 of hearts, probability of pulling 5 of diamonds, and she's keeping them. So she's not replacing them each time. Okay, so what I'm going to do is that's not the deck. In case you forgot what all is on a deck of cards, that is also going to be in our resources. So when we go to resources, we have cards in a standard deck of playing cards. And we can see that there are 52 total cards. Now, the very first card she wants to get is the 5 of hearts. There is only one of those in a deck. Okay, so for our 5 of hearts, there is one 5 of hearts out of 52 total cards. Okay, she's going to keep that. Now, she wants to get a 5 of diamonds. So how many 5 of diamonds are in there? Diamonds, 5. There's one 5 of diamonds out of, but there's not 52 cards in the deck anymore because Katie's holding one of the cards already. So now there's only 51 cards to choose from. Okay, multiply your tops, 1 times 1 and 52 times 51, which is 2652. That's not going to reduce because it's 1 over that, but you can check it. 1 divided by 2652, math, fraction, 1 over 2652. Now, if I make that a decimal, it does this little e to the negative 4. Let's see what happens when I multiply it by 100. Okay, so this is a very small percentage of chance because once I've multiplied by 100, this is way less than even 1% of a chance. This is a 0.04, I'm just going to go to 2 decimal places, percent chance. So even smaller than 1% that she will specifically pull those 2 5s. First the 5 of hearts, then the 5 of diamonds. Okay, all right, so those are our last 10 questions on the A versions. In the next video, we're going to see how we can use these questions filled out to answer the similar problems that are the B versions. All right, thank you so much for watching.